Science happens in the kitchen every day, whether or not we realize it. We experiment with flavor, combine acids and bases, play with density and states of matter, and so much more. In our science classrooms, we want students to be just as curious and creative. This is where the three dimensions of the next generation science standards help us to explore new ideas in a meaningful way. Students use practices to explore disciplinary core ideas that exhibit cross-cutting concepts. Or we could just say, what do we want to know? What are we going to do? How should we think? I noticed a pattern with bread. Most have yeast on their ingredient list. Sugar, water, and yeast are combined and added to the dough to make it rise. I planned to make a loaf of bread and I assumed I would need to use yeast. When I came across a recipe for Irish soda bread, however, I found this pattern to be broken. It called for only 4 ingredients: flour, salt, baking soda, and buttermilk. So, asking questions just like scientists do, I wondered how my bread would rise. I needed to find what caused this effect. My system included a recipe with a set of ingredients and instructions to follow. But what was so special about my ingredients? I observed their properties and realized that it was all about chemistry. The bread rising was observed at a macroscopic level, but the explanation required thinking on a smaller, microscopic scale about the molecules. Baking soda is a base and buttermilk is an acid, which react to produce CO2. I made the connection that just like yeast metabolizing sugar to give off CO2 and make bread rise, the baking soda and buttermilk reaction has CO2 as a product as well. This helps me to understand that CO2 causes the effect of bread rising. My pattern still holds true, but instead of bread rising because of yeast, it rises because of the CO2. Now that I am able to construct this explanation, I can engage in argument from evidence. Not all bread needs yeast to rise because rising was observed using other ingredients. I obtained information through research and investigation and am now able to communicate my findings to others, which is such an important aspect of science. But science is never done. There is so much more to explore. How does the thermal energy inside the oven cause changes in the ingredients of the bread? How do the proportions of ingredients affect the baked bread? I learned about acids and bases, which gave me so many more ideas to investigate.